So my name is Filippo Berto. I'm working in Sapienza together with Marcello that will take the second part of this lecture. I will make only a brief introduction of the topic, and after that I will leave the floor to Marcello that will give you some example of application of data-driven methods or machine learning or artificial intelligence, as you want to call, applied to structural integrity, which is the aim of this presentation. I want to mention that this work is under the umbrella of ERC proposal that we have received 2 years ago. And so today you will see some application related to that. Okay. Okay. So what I want to mention before is that there are a lot of challenges in fatigue design, and these challenges are at different scales. And so this has motivated us to introduce data-driven methods or artificial intelligence to approach the problem of fatigue at different scales with new advanced tools related to data-driven methods. In particular, what it is less understood up to now is how the crack initiate and propagate. The way is still very complicated and depends strongly on the material that you have to treat and to face. In addition, another important ingredient of our study is the bio-inspired design. What we have learned during the process of preparation of these projects is that natural inspired structures are really improved with respect to what we are able to produce ourselves. In particular, they are able to adapt to different situations, and for example, they are able to solve the conflict between strength and toughness that usually are conflictual properties. So if a material is tough, is not very strong. If a material is strong, usually the toughness is low. But the natural structures have the capacities to overcome these issues, combining and enhancing these two properties together. So, what we have done as preliminary study of this project was to study different kind of bio-inspired structures and to study only the static properties to have an innovative design solution taking inspiration by nature. Okay. But of course, bio-inspired design is still at the beginning, especially dealing with fatigue, and especially in combination with artificial intelligence and data-driven methods. And we have, in fact, the possibilities to have a kind of new design space that is still missing, where we can create and generate a new generation of structures able to survive for a very long time against cyclic loading. So the aim of this project is taking inspiration by nature to design super-resistant fatigue structures. And we have, in fact, different examples of structures where, due to different mechanisms, for example, mechanical interlocking or other mechanisms that the nature is able to develop locally to improve the fatigue behavior of a structure, we are able to obtain a better fatigue life. This field is completely a new research field, open, and there are very few results, mainly due to few groups of research, and I want to mention here Professor David Taylor that is also attending this conference in these days. So you will meet him during the conference. So we have also published some preliminary results of this topic. What I want to mention is that if you consider fatigue and the history of fatigue, we start with the empirical solution when the first studies were carried out by Wheeler After that, there were a lot of theoretical efforts to try to describe analytically the solution that can provide us some tools for fatigue design. And later on, we take advantage of numerical simulation and finite element methods. But now, what it is happening is that we have the possibility to apply the data-driven solutions. And actually, we can have fatigue in a new data-rich world, which can improve, can be a kind of revolution for studying this problem in a systematic way. Okay? So what we have done as preliminary studies was to study the metastructures of the materials, the constitutive laws, and the load sensitivity to show the feasibility of this project. After that, Marcello will give you some details of the specific algorithms that can be used to face these specific problems, and will give you some guidelines for helping you to face the problem of structural integrity with the help or with the use of machine learning. Another important part of the project is that it is not only to design a good structure that is the problem. The problem is also the final production of these structures. We have a lot of advancement in manufacturing that allow us to control locally what is happening to structures at different scales. And so if we are able to find a new generation of structures from a design point of view, from a design perspective, now we have also the tools to manufacture these structures in a proper way at different scales. Of course, adding complexity to a structures, so additive manufacturing allows us to have complex geometrical features, increase the possibility to have defects, intrinsical defects due to the process. And we need to treat them in a proper way, okay? So, especially dealing with fatigue, this plays a fundamental role. Why I'm focusing so hardly on fatigue? Because if you consider structural integrity in general, 90% or more than 90% of structural failures are due to fatigue or cyclic loading. So, of course, instead, if you see the studies in the literature, for example, dealing with fracture toughness and fracture strength, you will find that 95% of the studies are on static loadings. Okay, and this is due because there is a clear separation between people that are material scientists working mainly on toughness and fracture, and real people and people that are engineers that are working on real fatigue or structural issues. And so what we want to do here is to try to merge these two worlds and try to connect the two parts together. Okay? So as I mentioned before, there is one of the key of this project is that we have different tools to study what is happening at macro scale and what is happening at nano scale down to the atomic scale. Okay, this is very nice because now we can see almost everything inside the material. And so depending on the aim that we have for our design, we can actually reach any kind of scale. Another important thing that after that Marcello will mention better than me is that we have different data-driven techniques that we need to be able to manage. Okay, I will not enter here in the details because Marcello will give you a clear overview. What it is for sure important is that we have this classification of machine learning techniques that are available up to now due to different researchers and different groups that have developed themselves different techniques around the world. And I'm reporting here like a summary, this slide that if you want, you can also have after the conference. Dealing with data-driven techniques, we can have the possibility to make regression, so predicting one or more scalar values from some input data that we have, or predicting qualitative labels. So this is classification, two different ways of approaching data-driven techniques. As engineers, what we have found, which is very, very important, is to study physics-guided neural network. Why? Because usually these physics-guided neural network help us to focus the algorithm in the right direction without wasting computational times and looking for wrong solutions of the problem. Okay, so as engineers, this is probably the best way to approach the problem. Another important aspect is that we have two ways of approaching data-driven methods. The first one is a method that is called structure to properties or forward design. So we have a given structure, and from this given structure, we can extract the properties of the structure. This is the more, if you look to the literature, 95 or 98% of the work are referring to structure to property or forward design. The second approach is property to structure. So we want to have some desired or target properties for our structures, and we want to design a new generation of structure that is able to have those specific properties. This is called inverse design. In the second case, there are very, very few examples in the literature, mainly on static loadings. So here, actually, we have a completely new research field that can be developed and done during the years. We are now ready with a lot of computational capacity, a new algorithm that will allow us to go in this direction of inverse design. Okay, so now I will leave the word to Marcello, that will give you different examples. He will also make a brief introduction about this topic. He is working with me inside this project. He is the best person that is developing all the algorithms that we are using inside the project. So I will leave the floor to Marcello to give you a very good overview and a very good examples of what can be done with these approaches. So thank you so much.